Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, thank you. So today I will talk to you briefly by way of giving a demo about what we're doing with the ADS, the Astrophysics Data System, which is a project funded by NASA and operated at the Smithsonian Astrophysical Observatory, which is a member of the Center for Astrophysics. So what we have here is what most people consider a portal into the astronomy and physics literature. And just to show you how the system has grown and what the traditional use of your average astronomer is, I'm going to show you this incredibly ugly interface, which actually astronomers use on a daily basis for mainly two reasons, to make 2 points. One is that you should never let a scientist design your user interface. But the other one is that it actually shows the richness of the metadata that we have, which is not just bibliographic metadata, which is the basic search fields that you see here, but it contains also information about additional things linked to the literature, such as data products, bibliographic groups, metrics used for sorting, and so forth. So what are we doing today? We don't want to force users to move to a platform or a system that they are not familiar with, but we're trying to build our next generation services using a much simplified model and yet allow those scientists who are used to our traditional interface to continue using that. So we launched something called ADS Labs, and this is the main search interface into it. What you can do is, through the click of a button, specify what you want to search for. And I'm going to search for, one of the most popular searches actually in the system is looking for people by name. So I'm going to search for the name of our PI, which is Steve Murray. And the interface will show the top results for that person. And you know, the innovative thing from our perspective is that now a lot of the complicated options are gone, but we have facets that allow users to further refine their queries. So for instance, here you can see that under the name Murray, S, we have actually a lot of different people that are identified here through this interface. So until ORCID or similar projects give us unique author IDs, we can now allow users who actually know the person to select the different spellings of the name under which this person might have published. And also, what we've introduced is a different number of visualizations for things that are related to the bibliography. So what you're looking at is an author network that shows basically you know, connections between different people. And this might be useful to identify, not only identify cases of name disambiguation, but also to identify the different groups of people that have collaborated with a person. So for instance, my name is here. You can clearly see that Steve collaborates with a small group of people who are interested into the information science aspects. So our project itself. And then other groups that are mostly have to do with X-ray research. So I'm now selecting one such persons, and then the interesting aspect of this is that we can then apply the selection back to the paper. So we use a visual interface to sub-select the list of papers that we had already selected, or we had originally in our search results. So among the things that we facet on are links and connections to additional things. So astronomers typically are interested in observing the sky, retrieving data, and then identifying objects in them. So if we look at, for instance, some of these objects, we can actually have additional information. one thing that we support is a view of the object itself in a Microsoft Worldwide Telescope. So I pulled up this frame already. As you can see, Worldwide Telescope knows about this knows about this object, or it did. Okay, I think it's loading up again. Worldwide Telescope itself is then linked back to results in our system, and then and to other databases. So what we're trying to do is bring together resources and visualization tools to allow users to actually explore the literature, and through the literature as a proxy to find data products and other interesting results. So of more interest might be a search about, let's see, what do I want to do? Weak lensing. So about gravitational lensing. So we're going to do a topic search. Actually, what I wanted to do was search, make the point that we have different metrics that we support. So we could, because we have 100% penetration in our community, we can actually count the clicks and downloads for each paper that is viewed by scientists. So I now did a topic search on gravitational lensing, which is an effect that happens when a massive body is on the line of sight of some objects. And I'm looking at the most popular papers about the topic. Here I find the first paper actually is one that caused the first author here, Adam Rees, to win the Nobel Prize recently in physics. So for each paper we have all the basic metadata, as you can see. And among other things, we keep track of citations, references. We have a view of similar articles. And what we can do is to actually look at keywords associated with the list of papers. I'm going to click on cosmological observations. So these are papers that have something to do with gravitational lensing and have observations that are used for cosmological studies. I could look at the keyword in context. So this is snippets from the full text that show me where the terms gravitational lensing have appeared, which again gives the user a peek inside the paper. And what I can now do is actually view the objects, the astronomical objects associated with this topic in a view of the sky. So these are all the papers that were discussed in the objects that we selected and filtered. And I can now subselect objects which have some particular properties. So at the moment I'm looking at the class of stars. I can actually get the object names thanks to our collaborators in Strasbourg, which maintain this database. And I can even subselect a range of these objects so that I'm now actually actively interested in a particular area of the sky, and the objects appear in this area of the sky. And once again, we can go back to a faceted view of the results of all the selections that I've done. So I've come down to 2 papers that have data about supernovae in this particular area. One final point, if we do again gravitational lensing. We also support these 3 different options for searching, which use collaborative filtering techniques to detect review papers or papers that are currently being cited or read. And okay, just to make a quick point, all of these are not curated lists, but they're obtained through the use of analysis of citations and metadata. And the data actually associated with these papers is just one click away. Let me give you an idea of how this is done. This is done through the collaboration of archives that maintain information about data sets which are cited in the literature. And this is a testament to kind of the way astrophysics has been curating its data set. So ADS is basically an aggregator of metadata, both about publications, about objects curated in the sky, and the data sets that have been collected through them. As you can see, this particular archive at Space Telescope contains not only the publications, but also linkages back to the literature, and each one of these links back to us. And that's all I wanted to say. Thank you.